Filip Verloy, Technical Evangelist for NoName Security. Thank you.
Cheers, thanks a lot. So I'll sort of spend the next 8 to 10 minutes or so talking about API security specifically. We've already mentioned that due to sort of the success of the IT department leading to more digital transformation, adoption of public cloud, multi-cloud, even things like IT infrastructure automation, and now also policy directives like open banking, for example, that a lot of this communication is now on the basis of APIs. So let's say some numbers are more than 80% of internet traffic is now API calls. So we definitely see that as a focal point. Hence the focus of our solution specifically on this.
It's astonishing. Over 80% of all internet traffic, API calls. It really gives you a sense of just how much of a huge thing this is.
Yes, and also an unknown thing to some extent, right? Because it looks like traditional HTTP traffic, and if it looks like HTTP traffic, that's how we'll try to protect it initially, but in reality it is not. So an absolute eye-opener, I think. When you look at APIs and API access, I typically liken it to building a house. So let's imagine you start by building the left side of the house. There's a really good understanding of how you get in and out of the house. There's a front door, there's windows you can look into. But then over time, what always happens is that you build an extension on your house. And that extension might have a different side door. It has a different window for sure. And typically, because you're moving so quickly, you're not assigning those new entry paths to your inline and traditional security tools like gateways, etc. And these now become unmanaged APIs. Or it was a temporary thing and a developer put it in for a test phase but forgot to take it out. So there's a lot more APIs than you're typically aware of. And then another thing that we always find is that the foundation upon which your service is built typically has anywhere from 30 to 50% of unknown APIs. And that's typically where people tend to get in because those are sometimes accessible externally as well. So that is a real focal point to start your API security investigation.
So based upon this, an API-specific security solution is something which you think that's essential to actually have something specifically looking at these kind of issues.
Yeah, and it goes back to what I mentioned earlier about business logic. So if you only look at the front door, as you put it, and you only see traffic coming in and traffic coming out, you're missing like 80% of the full picture.
Right.
So that's why we're sort of advocating for going deeper.
We look at these microservices we mentioned earlier. We'll talk about them a little bit later, but some of those APIs, they never come out the front door. They're what we call east-west traffic. So that's why when Filip says you really need to have a holistic view of your APIs.
And we don't want too much east-west traffic at the moment, from what I've seen on the news. Okay. Right. Sorry, Filip, carry on.
No worries. So basically at a high level, we have 3 pillars to our solution, and it goes back to, I think, the discussion we had earlier is where do you start and how do you protect yourself is, first of all, there's posture management. So you have services in production. So the idea is understanding the full discovery of the APIs that you have internally, because that's the first step. You can't protect what you cannot see. And then it's answering questions like who has access to those APIs, how are they changing over time, who's responsible for them if we detect an issue, so who do we talk to? So that's the posture management piece. Second, it's about runtime security. So can we, by looking at real-time traffic, really understand the business logic of the application, apply machine learning, not because it's the cool new thing to do, but because it really allows us to on an API by API level, understand how the application should look like, and then allows us to point out any anomalies that we can see over time. So one quick example would be, let's say I'm a retail organization, and I typically sell my product for, let's say, between $10 and $12. This has been going on for a number of months now, and all of a sudden somebody figures out how to buy that same product for a minus $10 discount. So this person is actually getting richer each and every time he or she buys your product. That's not normal behavior. But from an authentication, authorization perspective, it all looks fine. So it's really about how does the application look like in reality. That's going to give us the insight we need to actually protect it. And then the final piece is shifting left. So we spent a bunch of time on that already. So how can we incorporate good security hygiene earlier in the development cycle by helping these developers incorporate it into their, let's say, standard workflows.
Okay, you're saying you're going to help the developers introduce this into their workflow. They might say that the digital transformation project is being hampered by all these security requirements. Is that true? Is it hampering changes company wants to make?
Right. So I think, valid point. The idea is we have to make clear that the way that this operationalizes itself, or the way that it's used in reality, is as part of their normal workflow. And as long as we can prove that out, then it will be just like anything else they incorporate into their DevOps loop, rolling out new applications. Of course, the additional benefit here is going to be that they can now do it a little bit more confidently. So there is going to be an initial step back to be able to take 3 steps forward, I would say. So at a very, very high level, the way that it works in reality is, let's say you have a super application. So typically you have mobile applications, but more and more, you now have applications that allow you to do multiple things from one app. So it's really hard to understand the full extent of what the application is supposed to be able to do. That application or that mobile app talks to the actual backend infrastructure. And as we saw before, this could be fully on-prem, in the cloud, a combination of multiple things. So the idea is we want to gather all of that traffic in real time to build our understanding of that super application in this case, and then tell the security people something useful about its usage. So anytime we can see a misconfiguration or an anomaly, we can raise that event and help them take the next step into sort of safeguarding the app end to end. And that's only possible by sitting really deep inside of the application space, essentially. So that's why we're sort of in the back end, seeing all of that API traffic communicate. One recent example, and I'm a Coinbase customer, so I thought it was an interesting one. So this is from February 19, so super recent. This was a test API, a developer API, by the way, so it was never externally exploited. But the idea was you could go into the app, tell the application you wanted to buy, let's say 100 of some cryptocurrency. So what you would do is you would go in, buy 100 of a very cheap cryptocurrency, and just before you push the buy button, switch it to Bitcoin, which is the more expensive one, and get Bitcoin added to your account. So that's because there was no validation of that business logic and no validation of that field. So luckily there was disclosure by the people who found this, but this is a typical API-induced problem that we find with a lot of our customers.
Thank goodness that never went live.
So we're trying to answer like really simple questions at a high level, I think. So if you go to an organization and we ask them, so how many APIs do you have? That's typically a really hard answer to get back. So the idea is always start with a full inventory, figure out exactly what you have, and that way you can understand the full extent of the attack surface and what you need to protect against. Second question is then, if I know I have, in this case, 515 APIs, who are responsible for those APIs? Are they business-owned APIs? Are they IT infrastructure APIs? Are they somewhere in the middle of the Venn diagram? So that's another difficult question to sort of bring to bear. And then that's one of the added values here, is to try and understand and really help a customer figure out, okay, part of my infrastructure is running in Azure or AWS or GCP or OCI or whatever they're using. So who's then responsible for that piece of the infrastructure? Who's responsible for that on-premises Kubernetes piece of the infrastructure? Mm-hmm. So that's a really tough question typically to be able to answer. And then a quick example here on a typical API attack. So again, this is a broken object level authorization problem. So the question here is somebody logs in with a token, has a specific bearer token, which corresponds to a user ID, you see at the bottom of the example here. And this person is requesting his or her own user details. So in this case, this person gets a social security number back that corresponds to that user ID. So from a network level security perspective, everything looks fine, it's authorized, it's authenticated, everything is good to go. Typically what we see happening is that the same user can log in, same token, now forcibly requesting user details from a different user, getting them back in the response, and then it's up to a system that knows the application to figure out if this is a good thing or a bad thing. Because I could very well be an administrator that has access to the entire database, and I'm allowed to query this. So in this case, we figured out that this individual user, by looking historically and building that baseline, is not allowed to do that, so we are raising an alert on the basis of machine learning. And that's really the crux of the solution is you have to understand the business logic to take that next step deeper.
Yeah. So quite often it's an authentication issue. It's making sure that the query is actually authorized.
Yeah, and if it's if the person is authenticated and authorized, is he or she authorized to take that additional next step or see more of the database that they were supposed to see? Indeed. Final piece of the puzzle is that shifting left piece. Again, I took the screenshot here if there happened to be any developers looking at this session later to show them that it's really nothing to be afraid about. It's in their own well understood toolkit. So it's part of that DevOps flow, just integrating that security piece. So the final thing that I wanted to point out is that there's 3 vendors here in this session, right? So we're trying to protect against sort of next level cyber threats and so on. What I wanted to make clear is that it's about integration and it's about working together. So there's definite pieces where we focus on API security. There's other pieces where other vendors focus on, and it's about covering that entire gamut of the threat landscape to be able to protect an organization. We do have a demo coming up as well. So if you go to the BlueFort.Live portal, you can get additional info. And on April 8th, we'll do a real deep dive demo into the solution. To get you to see what it actually looks like.